In this video, we're going to sketch tangent and cotangent functions that have horizontal and or vertical translations applied. And then potentially mixed in with that could be any other transformation. So we're going to sketch any type of tangent and cotangent function. All right, so in the previous video, we sketched these types of functions, but there was no translations applied. And so to sketch with translations, all we're going to do is, for horizontal translations, the period the base period that we used to sketch in the previous video, we're going to figure out what the horizontal translation is and then move that interval, that base period sketching interval, right? And then we'll sketch the period and then just copy and paste it up and down the graph. For vertical shifts, all we're going to do is we're just going to find that base period, put the vertical asymptotes. If it's shifted horizontally, then shift it. And then when we go to sketch the period, just take into account that the x-axis has shifted. Okay, so when we look at this, we need to put this into a form to where we can see exactly what has been done to the x variable. So we want to factor out of 2, get the x with a coefficient of 1. Then we're left with x minus pi over 2. Okay, so now we can see that this is the base tangent curve shifted to the right pi over 2. And then the function is scaled down about the x-axis by a factor of 2. And that's all the only transformations that have been applied. So the period of a tangent and cotangent function is pi. So since this has been scaled down by a factor of 2, the period is going to be pi over 2. Okay. So now, without a horizontal shift, we would, if the period was pi over 2, we know for tangent we go plus pi over 2 divided by 2 minus pi over 2 divided by 2. That's the period we're going to sketch. So it would be pi over 4 to pi over 4. Okay. However, this has been shifted to the right pi over 2. So what's going to happen is this pi over 4, wherever that's at, is going to be shifted to all the way to pi over, it's going to be shifted to pi over 2. So it's going to be shifted from pi over 4 or minus pi over 4 to positive pi over 4. And then the sketching interval is going to be from pi over 4 to pi over 4 plus pi over 2, which would be what? Pi over 4 plus 2 pi over 4, all the way to 3 pi over 4. That's going to be the sketching interval, pi over 2 to 3 pi over 4. So let's do, okay, we'll go to pi. All right, 1, 2, 3, 4, 5. So this is minus pi over 2 minus 3 pi over 4 minus pi over 4. Okay, so again, we've shifted. It would start off, if there was no shifting, the vertical asymptotes would be here and here for what we're going to sketch. But this has been shifted pi over 2 to the right, so it's going to start at pi over 4. So let's draw the vertical asymptotes. And then end pi over 2 past pi over 4, which is here. Okay. So now we want to, we're going to sketch, within this interval, sketch the curve, and then just copy and paste it up and down the entire graph. So, okay. This is going to be a tangent, and it hasn't been flipped horizontal or flipped about the horizontal or vertical axis or anything. So it's going to end up being something like this. All right. We know it's going to pass through here. There's no vertical shift. If there's a vertical shift, we'd have to imagine the x-axis is shifted. Okay, but what we do is we need to plug in some points so we can get some guidance on sketching the graph. So we're going to plug in, let's see. So let's go like 1/4 of the way. So we have, it goes pi over 8, pi over 4. 3 pi over 8. So let's plug in 3 pi over 8. So tangent of 2 times 3 pi over 8 is 3 pi over 4 minus pi. 3 pi over 4 minus pi is 3/4 minus 1. So minus pi over 4. Okay, so tangent minus pi over 4 is minus 1. Okay, now we know it's going to be, it's kind of confusing because we've shifted, but it's going to act like an odd function within this period here. So we know that y of minus 3 pi over 8, or no, that's not right. Not y of minus 3 pi over 8, because that's what's kind of confusing about it. Yeah, y of minus 3 pi over 8 is going to be positive 1, but that's going to be over here somewhere. But we know that, so at tangent, okay, at minus pi over 4, we're going to be coming down here to minus 1. That means over here at the 3/4 point, we're going to be at that same value in the positive range. Okay, but let's see. Let's do, we'll go 5 minus 5. So each tick mark is 1/2. So tangent of, let's see, 1, 2, 3, 4, 5. So 2.5 is 1/4 of the way, and we're going to go down to minus 1. Okay, and then 1, 2, 2.5 go to plus 1. And you know, if you actually went graph this in your graphing calculator, the shape, I might not be drawing the shape exactly like it should look. And so if you want to get the shape more dialed in, you could plot some extra points. But this is in general what it's going to look like. So let me put, all right. Like that. So now let's just copy this up and down the graph. And there we go. Okay. So now we've got cotangent. Let's rearrange the around the x so we can see the transformation. So factor out a 3. We've got x plus pi over 12. So this has been shifted to the right, pi over 12, and then scaled down by a factor of 3 about the x-axis. So the period has gone from pi to pi over 3. Okay, so let's, I want to try and keep the axes like a consistent interval. I don't want to just make the, like I'm going to do pi over 4, each major tick mark pi over 4. So 1, 2, 3, 4, 5. It's going to be some, either intervals of pi over 4, pi over 2, pi over, or pi. So, okay, 1, 2, 3, 4, 5. Okay. So now with cotangent, the base period that we would draw would go from 0 and then out the period. So in this case, that would be, 0 to pi over 3. And we draw the vertical asymptotes at pi over 3 and at 0 and sketch from there. So, but we're shifted pi over 12. So let's, okay, every single tick mark is pi over 4 divided by 5 is pi over 20. So how many tick marks is pi over 3 and how many tick marks is pi over 12? Okay, so, well, pi over 20 is 1 tick mark. How many tick marks is pi over 3 divided by pi over 20. So pi over 3 is 6 2/3 tick marks. Now what about pi over 12? 1 2/3 tick marks. Okay. So we know we've shifted. Oh wait, no, we've shifted to the left pi over 12. So okay. We know that we've shifted, what was it? To the left 1 2/3 tick marks. 1 is about 1/3, 2/3. So let's draw this asymptote here. Okay, then we're going to go pi over 3 from here, forward from here. So let's see. Pi over 3 is 6 2/3 tick marks, but we need to subtract. Let's take this and subtract. So 5 tick marks. So we're going to pi over 4. So pi over 4 plus pi over 12 should be pi over 3. Pi over 12 plus, yeah, okay. So there's the interval. Now, let's see. Where is the midpoint of this? So take, this is the tick mark, how many tick marks pi over 3 is. Divide that by 2. And then subtract from that the pi over 12. So 1 2/3. 1 2/3, there's the midpoint. Okay, now this is cotangent, so we know, and there's no flipping, so we know it's going to be something like that. Now let's plug in the quarter points, and the quarter point, the 3/4 point. There's no scaling either, so we can do, let's just do 5 to -5. Okay, so let's see. This 6, here's the length of the interval. So let's divide this by 4. Length of the interval in tick marks. Okay, now where is that in relation to, so that means the quarter point is at the origin. Now what about the 3/4 point? So multiply this times 3. Now subtract the amount behind the origin we are. And so 3 1/3. I'm doing that so I can count 1, 2, 3, and there's the 3/4 point. Okay. So we need to plug in what is y of 0. That is cotangent of pi over 4. And then what is y of, let's see, that would be, so pi over 3 divided by 4 is pi over 12. Pi over 12 times 3 is pi over 4. So we want to do minus pi over 12 plus pi over 4. So 2 pi over 12, pi over 6. So cotangent of 3 times pi over 6 is pi over 2. Pi over 2 plus pi over 4. So that's 2 pi over 4. It's going to be 3 pi over 4. Okay, now the 3/4 point is, so let's see, pi over 3 divided by 4 is pi over 12. So let's add minus pi over 12. Add to that, we want to go 3 times pi over 12. So pi over 4. Okay, multiply pi over 4 times 3 over 3, you get 3 pi over 12, which is minus pi plus 3 pi is 2 pi, so pi over 6. Okay, so y of pi over 6 is cotangent of 3 times pi over 6 is pi over 2. So pi over 2 plus pi over 4. So pi over 2 is 2 pi over 4. So it's going to be 3 pi over 4. All right. So let's see. Let's do cotangent of 3 pi over 4 is minus 1. And that's going to be at the 3 1/3 mark. So, okay. 1, 2, 3 1/3. And then minus 1 will be here. And then at the origin, it's going to be positive 1. This is going to be minus 1. This is positive 1. Okay. Like that. And there we go. Okay. Here we just have tangent x shifted vertically 1 unit. So, all right, we could do, we'll just do, okay, the period is pi, 1, 2, 3, 4. So let's do minus pi over 2 to pi over 2. And then we'll do, okay. Okay, so we know that tangent is the period is pi, and it's centered about on the origin. That the period we're going to draw, it goes from pi, minus pi over 2 to pi over 2. So let's put the vertical asymptotes. Okay, but now we need to consider that it's like the x-axis is going to shift up in a way. So let's draw this in kind of a fainter color here, because it's not an asymptote, but it is kind of a shifted up axis in a way. Okay, so we know at the center it passes through. So we just treat this like the new x-axis. So we know the center is it passes through the x-axis, right? And it's going to look something like this. Okay, we can, let's see, we can solve for the actual x-intercept here. So when y is equal to 0, when does 1 plus tangent x equal 0? That's when, so when does tangent of what is equal to minus 1, right? You set y is equal to 0, you solve for x, tangent of x equals minus 1, so inverse tangent minus 1 is minus pi over 4. So, and that makes sense because we're going to be doing, like that. So we can put here, it's going to pass through here, and that's actually the quarter point. Now, if we think about this as the kind of the x-axis, we went down 1. So at the 3/4 point, we're going to go up 1. All right, and so yeah, we can sketch it with that. There we go. And there's the graph. Okay, so here, this is going to be minus cotangent x shifted up 1. So it's going to be cotangent but flipped about the x-axis. So, but there's no shifting horizontally, so it's going to be something like, so cotangent is typically like this. It's going to be flipped, but then but it's going to be going up 1, something like that, and then copy that everywhere. So, okay, we're going to go from, so with cotangent, we go from 0 to pi over 2, 1, or no, 0 to pi. So we'll do 1, 2, 3, 4. We'll do this. This will be pi. Okay, so there's no scaling about the x-axis, so we go from 0 to pi. No scaling or shifting about the x-axis. Okay, now there's a new x-axis. Let's do, we can do 5 to minus 5. So there's a new x-axis at, once again, 1. Let's try and draw that in faintly. Okay, so now we can, at midway, we're going to cross through the x-axis. All right, now we need to evaluate, let's do y of pi over 4. So that's 1 minus cotangent pi over 4. Okay. Cotangent. Okay, so cotangent pi over 4 is 1, so 1 minus 1 is 0. And so that's going to be the, yeah, it's kind of confusing. Not the 0 of the x-axis is going to be actually 0. Not the 0 of the imaginary shifted x-axis is actually going to be 0. So that we went 1 down. Now we're going to go 1 up at the 3/4 point. Okay. And there we go. And there's the graph. Okay, here we're going to be shifting 2 tangent x down 1. So we can once again do, let's do 5 to minus 5. Okay, so why not go ahead and draw in the new x-axis? Let's do that now, why not? At minus 1. Okay, now the period hasn't been changed, so we're going to be going from, in tangent centered at the origin, the initial period. So 1, 2, 3, 4, 5. Period's pi. 1, 2, 3, 4, 5. Okay, but the period hasn't been shifted. No shifting about the x-axis, so we can draw the vertical asymptotes. Okay, so now we're gonna go through at the center. We're gonna go through the new x-axis here, and then let's see. This is tangent. It hasn't been flipped. So it's going to look something like this. All right. Let's see. So where would the x-intercept be? Tangent x is equal to positive 1/2. It's going to be at pi over 4, but we can check. Or no, that's, let's see. So tangent of pi over 4 is 1. So yeah, it should be. Oh, no, because we scaled it, it changes things. So at tangent, so at pi over 4, you get minus 1 plus 2 is positive 1. Yeah, because it's been scaled up. It's not, typically at pi over 4 would be the x-intercept in this case without the scaling. But we scaled it up, so we're at 1 here. And therefore over here, we're going to be at, let's see, 1, 2, 3, 4. So we'll go 1, 2, 3, 4. Like that. So, and there we go. And that's the graph.